Hello friends, I would like to demonstrate how you can solve um, second order linear homogeneous differential equations uh, which have this form. Okay, um, as you can see, a is a function of a is a function of x, b is a function of x, and I've made a mistake already. C is also a function of x, and this has to be true in order for this to be a linear differential homogeneous equation. Okay, but in this case I'm gonna focus on this type of homogeneous equations where a, b, and c are not functions of x but simple constants. Okay, so uh, okay, let's see how you solve that. I'm not gonna get too specific. I'm not gonna explain exactly why we solve them this way. Khan Academy has a pretty good video explaining all of that, and I'm going to give you the link in the description so you can check it out. I'm just gonna show you the method of how to solve this type of equations. Okay, so the first thing that you must do is find the what we call the characteristic equation. The characteristic equation of your differential equation. Okay, so that's pretty simple to do. All you do is take your differential homogeneous equation and transform it into a polynomial. So it will have this form a, but instead of y prime prime we write r squared. R is a variable, plus b, and instead of y prime we have r plus c, and instead of y we have r to the power of 0, which is equal to 1, so we don't need to write it equals 0. So this is our uh, homogeneous equation, and this is its characteristic equation. Okay, so by solving this we're going to get two solutions, R1 and R2, and with both R1 and R2 we are going to get two particular solutions for the homogeneous equation, but uh, we don't care to know, at least now, we don't care to know the particular solutions, but the most general solution of our differential equation. So how do we do that? I'm gonna continue with an example. Uh, Basically, yeah, I'm gonna continue with an example. Okay, let's say that we had the equation y prime prime plus minus 3y prime plus 2y equals 0. Okay, now the next thing that we gotta do is find the characteristic equation of this uh, differential equation. So that would be r squared, because we have 1 uh, multiplied by y double prime minus 3 r instead of y prime plus 2 r to the power of 0, which is 1 instead of y, equals 0. Okay, now this can be written with some simple algebra, which I suppose you already know how. To solve this. This can be written okay. Now for this we have oh, I'm sorry, what I meant to write was this. This can be written in order for this to be true, either this is gonna be 0 or this is gonna be 0. So we have two solutions. The first one is r1 equals 1, and the second one is r2 equals 2. Because if we substitute either one of those here, we're gonna get the 0 that we want. Okay, so the first particular solution, the first particular solution, which I'm gonna call y particular 1, and we're also gonna have oh, nice, that's not proper English, but okay. And the second particular solution, we're gonna call that yp2. Okay, the first particular solution of our differential equation here is gonna be yp1 is equal to a constant c1 times e to the power of r1 x, and yp2 is gonna be c2, a constant c2 times e to the power of r2 times x. Now we already know r1 and r2 for this equation from our characteristic equation, which is 1 times x and 2 times x. Okay, so the general solution is gonna be simply, and the one that you want here, a differential equation doesn't have only one solution. As you saw, if you either substitute this one here or this one here, you're gonna get 0. It doesn't matter, there might be more, okay, but the general one, it's gonna be 1 your first particular solution plus your second one, which is this. Okay, and this is the general solution, and what you want, general solution. So I encourage you to go ahead and uh, substitute this here, and you will see that you will get 0. So instead of you go ahead and substitute this y here. Okay, you've got to, of course, first find uh, y prime, and then you're going to find y double prime, and then you're going to go ahead and substitute here, and you will find that this is indeed equal to 0. Okay, now you might ask, but how will I know C1 and C2? Well, to do that, you must have some initial conditions which are gonna help you find C1 and C2. The first initial condition can be, for example, that y of 0 is equal to 1, let's say, and y prime of 0 is equal to 2. Okay, this could be theoretically some initial position, some initial conditions, and they're gonna help you find C1 and C2. That's all for now. I hope that I helped you somehow, and I'm not perfect. I do this for the first time. Also, I won't say that I'm not a teacher. I am just a physics university student, and I just wanted to help. If you want to be more sure about what you learn, you can go ahead and watch the video of Khan Academy. I will have it in the link. Okay, again, thank you very much for watching, and I hope I helped somehow.